So we're continuing on with our 1.5 notes. We're going to skip ahead back to where we left off last time, which I think was perpendicular lines. We never defined those. So it's like on the bottom of the back side of the one page. Well, I figured my board was weird yesterday. It's like Mr. Olson had borrowed my document camera, so it it was like projecting weird. So my board is back to normal thing again. So we're going to talk about perpendicular lines, and then we're going to get into a whole bunch of different algebra problems involving these types of angles. And so the drawing you have here is an example of perpendicular lines. What do you notice about this drawing? What's special about it? What's unique about this drawing? Or what do you see in general? Maybe it's not even unique. What does this drawing tell us? There's something there that's marked for us below. Thank you. Does anyone see it? Yeah, go ahead. There's a box at the right angle. So the fact that these two lines intersect and there's that little box that's a right angle, that's what perpendicular lines are. They're lines that cross at a 90-degree angle. For the notes we started last class, and then we're just continuing for today, so we're just in the bottom down here. So I'm trying to have them filled in for you till then. So perpendicular lines are lines that cross at a 90-degree angle. So the fact that Lena pointed out that little 90-degree there, that tells us that these lines are going to be perpendicular. So they're lines that intersect at a 90-degree angle. So they intersect at 90 degrees. Now, if this one is 90 degrees, knowing what we know about angles now and lines, what can I conclude about the other angles in this drawing? Yeah. They're also 90 degrees. Can you guys see that? So this is a straight line. If this is 90, together they have to be 180, so this also has to be 90. If that's 90, this one has to be 90. And again, that could also be because of those vertical angles we learned about last time. This is also 90. So if we have one 90-degree angle at that intersection, all of them are going to be 90 degrees. So there's actually going to be 4 right angles. And all we have to do is tell us the one. We can assume all the other ones are going to be 90 because of what we know about the angles. Now, perpendicular, since it comes up a lot, like again, I mentioned this before, 90-degree angles show up all over the place. There are like almost more perpendicular lines than you can count on this wall. And don't try to count the bricks on the wall. I once had a kid who, like, I could tell he was like counting the bricks, like what a great use of his time. But you know, like, so there's more intersections than you do want to count. Bill, don't think about it. But so, counting the bricks. And same thing with the tiles on the floor. I mean, there's all these perpendicular lines everywhere around us. So it's used an awful lot in geometry, but also like kind of in the real world. So there's a symbol for this. So first of all, we have 2 lines intersecting. So line AC and line BD. And we have a special symbol to show perpendicular. And it looks like an upside down T. So that little symbol, an upside down T, would tell me that those 2 lines are perpendicular. So if I see something like that, I would know that those lines are perpendicular. So your book could say that, and you would know that those lines intersect at a 90-degree angle. I could write that, or I could say, like, write a symbol that shows that. It tells us that they intersect at a 90-degree angle. This mark also tells us that, so just remember kind of those those clues they give you to tell you things intersect. All right, so let's actually go back to the example, or go forward. We're going forward, but we've already kind of done this one. I want to talk about this example again. So if you go to the next one, we kind of marked it all up, or I did. You might not have. I'm going to erase a little bit of what I did just because it's kind of hard to see when I have marker over marker here, or whiteboard over whiteboard. What I want to point out is kind of some of the information and kind of some of the things maybe we could figure out based off of this drawing. Now, they tell me this angle is 110 degrees. So this is kind of a little bit of a review from yesterday. Can I tell anything else about any of the other angles in this drawing based off of that 110? Yeah, what do you think, Izzy? Yeah, she wasn't even here yesterday. She said, so she tells us that if you use this one, would be 70. You could also go this way, that this one would also be 70. And how does she know that? Like I said, she wasn't even here yesterday, and she was able to tell us that. Why? How do we know that? Yeah, go ahead, Izzy, explain.
Because
yeah, there's a straight line here, there's a straight line here that tells us that those better make a straight line together. So if that's 110, this is also 70. Same thing this way, this is also 70. Again, that 70 mark is a little bit weird because it crosses two angles, so that might be a little harder to mark. What else do you guys know? Somebody else tell us. What else do you guys know? Something else we know for sure. About the angle measures. What else do we know? Yeah.
STE is 110 degrees.
Okay, so STE, this is 110. How do you know that, Michael? There's a couple different ways you can know.
It's the vertical line.
Very good. So that's actually the one I wanted to talk about, but you could have used another reason. So he reminded us that we have something called vertical angles here. So remember, vertical angles are that intersection, and they're across from each other at the intersection. We learned that vertical angles are always equal. So if this is 110, this also has to be 110. Or you could use what Izzy had suggested, that this forms a straight line, and if I know that's 70, kind of leaves that to have to be 110. So there's a lot we can assume if we know vertical angles and we know linear pairs. And those are two things that we can assume in drawings. I can assume straight lines, and that forms linear pairs and vertical angles. There's kind of a lot we can figure out just by looking at a drawing like this. Now, can I tell both of these are 35 degrees? So 35 and 35? What do you think? Is it safe to assume that? So I felt some of you guys nodding, and then once I kind of like waited, some of you might realize, I don't think anywhere I tell you that this is a bisector. They look like they could be congruent, but we don't know that for sure. So you cannot assume that this is cut in half. So I can't say those have to be 35 and 35. What if one of them's 34 and the other one's 36? Could happen. We don't really know. They don't tell us enough information to tell us that those two are congruent. So unless they tell you it's like a bisector, we can't assume that those are both 35 degrees. It's possible, but it's also possible they're not. Like it's possible, you know, one is, like I said, one's 30, one's 40, one's, you know, just like slightly off. But so just that you guys know that you can't assume those, like, even though they look the same, they're not necessarily the same. All right. So let's look at the next examples. So 5 and 6 here. So 5 and 6, so we're finding the values of x and y so that these are perpendicular. And so I said that without even thinking. So being a math teacher, I see a symbol like that, and I don't even need to think about the fact that that upside down T means perpendicular. It's just so second nature to me. Again, it's probably like Mr. Sampson, who's taught Spanish for so many years. He probably looks at a Spanish word and just can translate it that quickly. Same idea with this. So as you guys see this more, you'll see it and think perpendicular. I've had students have gotten to the test and been like, I've never seen that symbol before. So hopefully, like, that's not the case for you and that you're somewhere in between those two things. But getting used to seeing that upside down T means perpendicular. So they're saying find the value of x and y so they're perpendicular. Well, first of all, they have it marked for us, so it kind of already is perpendicular. But we want to see, how do I figure out x and y to make sure these are perpendicular? So anyone have any thoughts on how to do that? Do you want to walk in the picture? And take yourself, give yourself a mask right there. Oh. Just keep coughing in your mask would be great. Poor thing. So anytime, guys, let me know. Like, again, if you haven't been doing it already, drinking water that keeps you extra healthy, and give yourself little breaks. It's fine, but yes. All right. Any thoughts on how to do this? Any thoughts? And there's like, to find x, you're going to do one thing. To find y, you're going to do something different. So either one you guys notice. Anyone see anything we can do? Find either. Drake, you started writing. Did it not work out? What did you try doing? I saw you writing. So he worked on y, right? So would you tell us what you wrote, Drake?
I had 9y plus 18 equals 90 because it's perpendicular.
Yeah, so remember when we have a 90-degree angle or we want it to be perpendicular, that means they all should be 90. So this should also be 90. This would be 90. We'll talk about that up there in a second. So all of those should be 90. So we're saying 9y plus 18 better equal 90. So we should be able to solve this to figure out what y would be. Now you might say, well, that doesn't help us with x, but we can wait on x. It's okay. X will still be there when we finish this. So this becomes a pretty simple algebra problem for us to do. You breathe again?
Yeah.
Oh, good. So we find out that y is 8, right? All right, thoughts on finding x. So we found y. What do you guys think about x? Any thoughts there? Now, yeah, go ahead, Noel.
So I did 5x plus x is 6x.
Yeah, so sometimes like this big drawing might just be throwing you off. Look at the part that we just care about for x, or maybe even just like the top half of this drawing. I know that if this is 90, these two together better be 90 as well, right? Because they make that corner. So together, these two should add up to 90. So what he's saying is he took 5x and x, and it better equal 90 as well. So we write a whole different equation to find our x value. So 5x and x is 6x. And then 5 by 6. What do we get for our x then? 15? Okay. Oh, and then it says find MSN. That's not very helpful. That's not a very tough angle to find. MSN's right there. It's 90 degrees. I guess I don't know why that question was there. Kind of a simple one. All right. So if you guys flip the page, we have a word problem, so that means we just skip it, right? That's what I do with my homework. No. We're going to talk about it and see if we can figure it out. And then we're going to take a little notes break and do some whiteboards, and come back and finish the last examples, and then we'll have time for homework. So a little bit briefer day because we got through so much. Which reminds me, I probably should have done our vocab chart. Shoot. I guess we'll do that tomorrow, but got that. We do that. I have a vocab chart for us that we can write down all the vocabulary we learned so far this year. And so you kind of can use that to study. I should have done that for today. That would have been a good kind of thing to do, but oh well. All right, so the measure of an angle supplement is 76 less than the measure of the angle. That's a lot there. I'm going to think about what they're kind of saying in a second here. The measure of an angle supplement is 76 than the measure of the angle. 76 less than. What does supplementary mean again? Supplement of an angle. You guys remember? Yeah.
The two more angles add up to 100.
Yeah. Remember? Yeah. 180 is supplement. Complement starts with C, so that one's 90. Because remember, C comes before S. You're like, what does that have to do with 90? C comes before S, so complements add to 90, supplements add to 180. So I might draw this. So the measure of an angle supplement is 76 less than the measure of the angle. So 76 less than. How do I write that algebraically? How do I write that with math numbers here? 76 less than. If I said you have $76 less than your brother, how would you write that? How would you figure that out? Your brother's money minus your 76, right? So we're going to take the angle and subtract 76 from it. I'm going to make the smaller one be x minus 76. I'm taking that angle and subtracting 76 from it. The angle we're talking about is the other one. The two together are the complements that add to 180. So this becomes an algebra equation we can write. These two together should add to 180. And so if you guys want to take a minute to solve that, give you guys a second to try it. And again, so it's saying 76 less than the measure of the angle 76 less than that. And some of you guys might have set it up a little bit differently, but then others of you like had no idea how to start. So this is how I would suggest setting it up. All right, so hopefully you realize that together they should add to 180. So x plus x minus 76 equals 180. X and x is 2x minus 76 equals 180. Move that 76 over. Right, because we already had less, so we had to move that over. Yeah. And I think this is 128 then for our x value. This one, right? Find the measure of the angle and its supplement. So 128 is going to be our angle. And then the supplement is 76 less than that. So you're going to do 128 minus 76 should give you that other angle. So 128 minus 76, what do we get?
52.
52. 52 and 128. All right, so we're going to take a little bit of a notes break to do some whiteboards. Sorry, right now, like with trying to keep things distant, I don't have a whole lot of great like interactive ideas other than Kahoots and whiteboards. I'll keep working on things, trying to find different stuff for you guys.